3.5. Let's get a clean sheet of paper. 3.5, which was on rational functions. Now, the very first thing on rational functions that we have to know how to do is find their domain. And if you struggled with finding the domain in that section, you can go back to section 2.6. There's a few extra problems from 2.6. Actually, finding the domain of rationals starts in 2.6. They covered it there, but then it gets brought back up. So 2.6. Now, make sure to understand that on the test, this will be answered in interval notation. Okay, it won't be like x can't be 4, x can't be 5. It'll be an interval notation for the domain. But from the domain, from the restrictions on the domain, we know we could have one of two things, right? We could have a hole, or we could have vertical asymptotes. So know how to find if we have a hole or vertical asymptote in that section. I know if you go back and watch the lecture, you'll see we talk extensively about these topics. So the whole vertical asymptote, and then also you have horizontal asymptotes.
Can you talk about horizontal asymptotes?
Finding horizontal asymptotes. And the last thing in 3.5, which was really the first thing in the homework, was identifying information from a graph of rational functions. So for the bullet point here, I'm just going to give the homework that I'm talking about, so you kind of makes it a little more clear. It's on page, let me find it. I'm almost there. Page probably like 402 or something like that. Nope, not 402. Page 406. Numbers 9 through 19. I mean, I guess I'll do odd because we did odd, but there's going to be two questions that are like page 406, 9 through 19. It's where I give you a graph, and then I ask you, as x approaches a number, what's f of x headed towards? So we went over that in the lecture, and in the homework. So it will definitely be asked on the test. Okay, so those are the topics on the test. And I'll tell you, this section has the most questions from it. Of the 17, this is the most from any section, because the other two are really a lot shorter. Like in 3.6, it was just inequalities of quadratic polynomials. And this is the one I'm going to do an example of this one to show you how on the test it kind of gives the answer. And I'm not a fan of how they did it, but I feel like it's important I need to go over it so you don't get confused by how they're giving you the answer. So the question will look something like this, where you just have to solve it. You've got x squared minus x is, let's say, less than 6. Okay. Now remember, so we've got to solve this out. We got to find where this quadratic is less than 6. So to do that, first I've got to move the 6 over. So I get x squared minus x is less than, x squared minus x minus 6 is less than 0. And then we've got to graph this, but really what matters is we find where it crosses the x-axis. So x squared minus x minus 6 equals 0. I'm going to graph this here in a minute. But if I solve this out, I get x minus 3, x plus 2. So x equals 3 and x equals negative 2 are going to be our boundary points, right? So if I graph this one, negative 2 is here. Positive 3 is here. Let's graph it. I've got a few other colors. Hold on. It's something like that, right? We know it's quadratic. The A is positive, so it's smiling. But what matters is we have these boundary points at negative 2 and positive 3. Now the question asked, where is it less than? Now remember, less than means below the x-axis. So it's below the x-axis between negative 2 and 3. So the solution actually, and this is how it's going to be written. So, this is multiple choice, right? We got A, B, I'll just do like 3, even though I know there's going to be, say D is just none of the above. Well, A, let's say A is the actual answer. It goes from negative 2 to 3, and it doesn't include the endpoints because it's a less than. So negative 2 to 3. It's going to give you the interval notation, but then also it's going to graph it on an X number line. And this is what I'm not a fan of, but I want you to realize that it will have the interval notation there for you. So it'll have like negative 2, and 3's out there, and then it'll say this. Okay. So note, these are the same exact thing. It's just one is interval notation and one is the number line notation. So maybe B is like, where you include the endpoints. They'll do a bracket in between here. And maybe C is where you don't, it's the opposite. So you've got negative infinity to negative 2, and then union 3 to infinity. So on a number line, it would look like this. It would go, we got negative 2, 3. It would look like that. We got negative infinity, positive infinity. Okay, but notice you can just look at the interval notation. You don't have to worry about the line notation or the graphing notation. How we answered it in the class is in the answer. They just put the other part in there too. Okay, so I wanted to go over that so you don't get confused when you start solving it and you see this linear or this line with that notation, the graph notation. Not a fan of it, but it included it. Okay, but that's 3.6. So 3.6 inequalities of quadratics, given a quadratic, and you just have to solve it out. And you got to find where that quadratic is either above or below the x-axis, right? This one's less than, so it's below. Okay. And then lastly, 4.1. First, it's over, actually, this is just exponential functions. First, it's just how to put in a calculator. And if you did the homework, it's the very beginning of the homework. And it's just, like 2 to the pi or 4 to the negative 1/3 or 4 to the negative 0.3. It's just how to use your calculator to put exponential terms in. Easiest question on the test, okay? Then I'm going to put in an application of an exponential function. And if you saw the lecture, you'll know what I'm talking about. In the lecture, I talked about gray wolves, the gray wolf population in the northern Rocky Mountains. That's a perfect example of an application of exponential functions where I'll give you an equation and, the equation will pop out the size, and the X maybe is like the year after 1980 or something like that. That's the example of the gray wolf population. But, and you'll have to know, okay, if I wanted the year 2000, that's X equals 20, and I plug it in and I get back an answer. So application of exponential functions. And then lastly is compound interest. Compound interest, now remember we had non-continuous and continuous. I spelled it wrong there. That's fine. Non-continuous and continuous. Okay. That doesn't look right. Doesn't matter. So I'm going to ask you the compound interest question the way it was asked in the homework. So if you did the homework, you've seen actually all these if you've done homework and all the ones before this. So how to put it in your calculator, and then the application of the exponential function, and then how to calculate compound interest. And really the question will also look like, hey, if you've got these two options with compound interest, which one should you do? Which one will you make more money at? And if you did the homework, those are both in there. Okay. Those are both in there. any questions so far? I'm going to choose some examples I think are best. Like if I made a study guide, choose some examples from the book that I think you should focus on. But before I do that, do you guys have any questions before I choose some examples?
I have a question.
Okay, you got to speak up. I can barely hear you.
Sorry. Could you talk about horizontal asymptotes? I'm not good at telling the difference
Right,
between.
CJ, I can't hear you at all. Hold on. Okay, what was it? Horizontal asymptotes. Yeah, have you watched the video on horizontal asymptotes and done the homework? Okay. Well, okay. So maybe let me kind of go through these, and I'll talk a minute when I get there. Okay. So yeah, let's talk about 3.5. So 3.5, what I would focus on from the homework, and I will, CJ, I won't leave you hanging there. 3.5. I would focus on that 9 through 19 odd, because I'll tell you, students have a lot of problems when it comes to that first 9 through 19 odd. Yeah, students have a lot of issues with kind of getting information from a graph. And then I would look at, I would say 21. 29, and then 33, and then let's do 37, 43. These are the horizontal ones. I'll do an example like that here in a second. And then putting it all together, like 57 and let's say 69. Okay, so these are all good examples from 3.5. Like if I was going to make a study guide. Okay, hold on. I'm gonna get a clean sheet of paper. I'm gonna come back to that one though. For the come on now. Why can't I get this piece of paper? So if I wanted to find a horizontal asymptote, if I had f of x equals, let's say 2x minus 1 over 3x plus 1. Why not? And I ask you to find the horizontal asymptotes. It's based off the degrees of the polynomial. So I've got a degree of 1 on top and a degree of 1 on bottom. And if they were the same, then it was the ratio of the leading coefficients. So y equals 2/3. That was my horizontal asymptote. Now, if the degree, I'm going to use the same kind of numbers here, but all I'm changing is the bottom degree. If the bottom degree is larger, so this is a 2 and this is a 1, if the bottom degree is larger, it was y equals 0. Okay, so this could be like 4 or 5, what doesn't matter. If the bottom degree is larger than the top, then the horizontal asymptote is just 0. Now, if the top is larger, there's just no horizontal asymptote. Okay, no horizontal asymptote. So that was the 3 things that could happen, CJ, with horizontal asymptotes. So if they're the same, we do the ratio of the leading coefficients. If it's larger in the bottom, the degree is larger in the bottom, which is y equals 0. And if the degree is larger on top, winds up being no horizontal asymptotes. So that was the 3 things that could happen with the horizontal asymptote. Does that help? Can you tell from the graph, is there a horizontal? Yeah, because it'll start dying out. It'll go closer and closer to something. So like this graph right here, what you'll see, actually, I don't know exactly how this one looks, but what you'll see is if it's a horizontal, it'll start fading out like this, like that. Okay, so I know there's a horizontal here because these are headed towards a flat line. You see that? So that's how you can tell from a graph if we have a horizontal asymptote, because the end behavior is settling out towards a number. Okay, it's flattening out. Okay, perfect. Sweet. Okay, so let's go back to 3.6 now. So if I was going to choose a few examples from your homework in 3.6 to look at. I would do like number 5. I'm going to choose some odd ones so you have the answers. Number 5, number 9, and 13. 5, 9, and 13. All solid examples. Actually, I wouldn't even worry about it. Don't worry about 9. It's got a weird answer. So let's say 5, 13. Yeah, maybe even 17. Okay, 5, 13, and 17. Those are all good examples from 3.6. Okay. And then 4.1. Oh, yeah. Like this is the easy steps at the very beginning. You'll see what I'm talking about. Like number 1 or number 9. And then the application. So let's say, they don't get to the application until later. So let's do the compound interest question. 53, 55. And then the application would be like 65 or 75. So these are the application. This is the compound interest. These are from the homework, Justin. So like it's just the homework in those sections. So this is page 452. This is page. Hold on. Page 420. And this is page, actually, something. 406 is where it starts. Okay, yeah, those are the 3 pages. So yeah, we've got kind of basic stuff 1 to 9, and then this is the compound interest question and how it'll be asked. And then 65 and 75 are the application question that I was talking about up here, the application of exponential functions. So this is a good study guide for this test, okay? This would be a good study guide for this test. Okay, I'm gonna pause it right here. Well, I'm not pausing anything, but do you guys have any questions? I'd make sure to get the homework done. I mean, it's not, there's only 17 questions and you have time to get them done, but they're going to take you a lot longer if you haven't seen them before, then you have to work through them compared to whenever, you first get started. Okay. Questions, comments, questions about anything else, like anything math or school related. I'm open. We got some time. Trying to think. Oh, hey, guys. Yeah, I can talk about this. We can go on kind of a left-hand tangent here. Advising for, hold on, let me go. Let's see my face. No one's in here right now, so it's fine. Advising for the spring semester has started. So you need to get with your advisor as soon as you can to get classes. I don't think we're going to have to worry about classes getting too full too quick, but I would get with them so you can get your schedule made as soon as you can and get it made correctly. I will say we're offering a few different, now that we've gone through this semester, we're offering a few different modalities is what they're calling them, which is just how we're delivering the classes. So if you want seated, we're doing a lot more seated. Actually, we're going to have at least one. I know you guys are in college algebra now, but we are offering a fully seated college algebra class. It's going to be in like a huge auditorium room, and I think they're doing that with some English classes as well. So it doesn't have to be this like half Zoom, half seated fiasco we're dealing with. Okay. But get with your advisor soon. If you're not sure who your advisor is, it's in Campus Connect. When you go into Campus Connect, it's on your profile. If you don't know, you can email me and I'll find out who your advisor is and I can point you in that direction. I don't mind doing that at all. Okay. Also, go vote. I know I said it before. It's a big deal. Yep. And I'm not going to be like hyperbolic about it. It's not, oh, it's a bit of a selection, whatever. No, just go vote. And then we can complain about things later. Okay. I really need to shave. I don't know how bad this is getting. Do you guys have any questions before I let you go? I know I've only had you for about 30 minutes, but